In this lesson, let's take a look at how combinatorial explosions arise in software testing, and how combinatorial explosions make it impractical to test every possible permutation that we can imagine. We'll cover why isn't testing everything practical, how combinatorial explosions happen in software testing, and we'll look at how permutations grow exponentially. First, let's start with the story of paper folding to the moon. If you could fold a piece of paper in half enough times, it would reach the moon. It turns out the number of folds it would take is far fewer than most people would guess. With 0 folds, it would be 1 piece of paper thick. After 1 fold, it would be 2 pages thick. After 2 folds, and this is key, it would not be 3 pages thick, but 4 pages thick. It would double from 2. After 3 folds, it reaches 8. After just 20 folds, that height would reach as tall as Mount Everest. It would double and double and double again. After 41 folds, the height would now be halfway to the moon. With your 42nd fold, you would get fully from the Earth to the moon in height. The story of software testing combinatorial explosions works in very much the same way. Let's take a look at this sample system under test, where you have an applicant applying for a loan for some property. And in each of these, we have, in this case, 9 parameters. The first parameter would involve credit rating. Second parameter, applicant income. We have applicant status as well. And without going into all the details right now, let's just look at how the combinatorial explosions would start to emerge in this relatively simple system under test. If we just had in scope 1 parameter with 3 values, there would be 3 possible tests. 1 for high, 1 for medium, and 1 for low applicant credit rating. If we added a second parameter, the applicant income, and that could be large, moderate, or small income, we would have a total of 9 possible combinations. I'll interchangeably refer to permutations, possible tests, and possible total number of combinations. I mean exactly the same thing with each phrase. If we added a third parameter, we'd now be talking about 3 times 3 times 3, or 27 possible tests. A fourth parameter that had 3 values would get us to 3 times 3 times 3 times 3, or 81 possible tests. How does that work? How do we go from 27 possible permutations to 81 by adding one parameter? Well, you can think about it this way. After 3 parameters, we had these 27 possible permutations. Test number 1, high applicant credit rating, a large applicant income, and an applicant status of VIP, and so on. For each of those 27 scenarios, we could now add one of these 3 values to come in at the 4th or final step of our 4-parameter set of tests. So these 27 scenarios now could be added 27 of those identical scenarios ending with short duration of the loan. Another 27 that started at identical will now have a 4th value of medium duration. Another 27 possible scenarios will have a duration for the loan of a long loan duration. So you get 27 plus 27 plus 27, or 81 possible permutations. And that math continues. We'd have 243 possible tests if we had 5 parameters in the plan. Adding a 6th parameter would triple it again to 729. 7th parameter would get us to over 2,000, and the 8th parameter to over 6,000. And now we're really growing in leaps and bounds. The 9th parameter would take us to almost 20,000 possible permutations. Let's now jump back into Hexawise to look at another example. This one has 5 parameters, which means we'll multiply 5 numbers together to figure out how many total possible permutations exist for this system under test. There are 2 possible CPUs, so we'll have 2 to start with, multiplied by 2 browsers to get to 4 possible permutations, multiplied again by 3 to get to 12 possible permutations. 2 possible protocols gets us to 12 times 2, or 24 possible permutations. And then 3 operating systems. If we ignore any possible constraints or invalid pairs, we'll get 24 times 3, or 72 total possible permutations, or total possible tests. You'll note that every time we create a set of tests in Hexawise, when we click on the Create Test buttons, it will tell us these numbers. It will calculate out a total possible 72 tests in this example. So, what are some key takeaways from these lessons? Well, first, it's important to note that total possible permutations, or the total possible number of tests in your systems under test, will grow exponentially. Secondly, it's very easy and straightforward to calculate the total possible number of permutations in any system under test. How many numbers you need to multiply is going to be a factor. It's going to be determined by how many parameters you have, and which specific numbers you need to multiply together is going to be determined by the different number of values you have per parameter. In the first example, we multiplied 3 times 3 times 3 9 times because there are 9 parameters. Each parameter had 3 values. In this second example, we multiplied 2 times 2 times 3 times 2 times 3 to get a total possible number of permutations of 72. Next, we'll look at how the required number of two-way solutions, or pairwise tests, grows very, very differently in the face of these exponential explosions in possible tests. Thank you.